All right, let's talk about Docker. If you've used it for more than, say, 5 minutes, you have absolutely hit a weird problem that just made you stop and scratch your head. Well, today, we are going to dive into some of the most common, most frustrating Docker issues and show you exactly how to get past them.
Okay, let's start with the all-time classic, the one that gets everybody. You run your container, you see the ID pop up, and then, poof, it's gone. It exits immediately. So frustrating, right? But the reason is almost always the same. A Docker container only stays alive as long as its main process is actually running. If that process finishes or crashes, the container's job is done and it shuts down. So in this first section, we're going to tackle the two main ways containers seem to misbehave: by vanishing when they shouldn't, and by yelling permission denied for things that work just fine on your own machine.
So how do you figure out why that main process stopped? Well, here's your 4-step playbook. First up, always check the logs with Docker logs. That's where the error messages are hiding. If that doesn't give you a clue, take a look at your Dockerfile. Is the CMD or entry point what you think it is? Still stuck? Try running the container interactively. That drops you right into a shell inside it so you can poke around. And finally, check the exit code. 0 is good, anything else is a signal that something went wrong.
And you know, a lot of the time, that whole exiting container thing really just boils down to a mix-up between CMD and entry point. The easiest way to think about it is this. Entry point is the verb. It's the fixed command that always runs, like Python. CMD, on the other hand, provides the default nouns, the arguments for that verb, like app.py. And the key difference is you can easily change those nouns when you run the container.
All right, on to our next classic headache, your script. It works perfectly on your laptop. You copy it into a Docker image, run it, and bam, permission denied. What gives?
And this right here, this real-world example, it explains everything. You have to remember, a Docker container is its own little universe. It has its own file system, its own users, its own permissions. Just because a file is executable on your machine doesn't mean it will be inside the container. You often have to explicitly tell Docker to make it executable, usually with a simple run cmod plus x command in your Dockerfile.
Okay, next up, let's talk networking. This can feel like a total black box sometimes. We're going to clear up a huge point of confusion and then solve the #1 reason you can't actually connect to your running app. First things first, let's bust a huge myth right now. The expose command in your Dockerfile does not open a port. It doesn't publish it, it doesn't make it accessible. Think of it as just a sticky note, a piece of documentation for yourself or other developers to see which port the app is supposed to use. It doesn't actually change the network configuration at all.
So you're smarter than that. You know not to rely on expose. You correctly use the -p flag in your Docker run command to map, say, port 8080 on your machine to port 80 in the container. You go to your browser, type in localhost 8080, hit enter, and connection refused. What is going on now?
And here it is. This is the secret 9 times out of 10. Docker is doing its job. It's forwarding traffic from your machine to the container. But if the application inside the container is only listening for connections from localhost or 127.0.0.1, it's basically only willing to talk to itself. It sees that traffic coming from the Docker network and rejects it. The fix, you have to configure your app to listen on 0.0.0.0. That tells it to accept connections from anywhere, including the traffic that Docker is kindly forwarding to.
You know, one of Docker's greatest strengths is that containers are disposable, or ephemeral. But that very feature leads to two really common puzzles. Why did all my data disappear? And why aren't my code changes showing up?
Oh, this one hurts. You're running a database in a container, or maybe an app that saves user uploads. Everything's working great. Then you have to restart the container for some reason, and poof, everything is gone. It's because by default, any data written inside a container's file system is wiped clean when that container is removed.
So the solution is pretty simple in concept. You have to store your data outside the container's temporary file system. And you've got two main tools for this. Docker volumes are the way to go for production data. Docker manages a special area on your host machine to keep that data safe. For development, though, bind mounts are amazing. They let you link a folder from your computer directly into the container, so any code changes you make show up instantly without a rebuild. Okay, this next one will make you question your own sanity. You find a bug, you fix the code, you patiently run Docker build, you start the new container, and the bug is still there. It's like your changes were completely ignored. This maddening problem almost always comes down to one of two suspects. First, it could be Docker's build cache being a little too clever.
It might see that nothing before your copy command changed, so it just reuses the old layer with the old code. You can force it to rebuild everything with the -no cache flag. The other, sneakier culprit is when you have a bind mount that's mapping your old local code over the brand new code you just built into the image, effectively hiding all your hard work.
All right, for our final section, we're going to cover 2 absolutely essential skills for anyone using Docker day-to-day: how to clean up the mess that Docker inevitably leaves behind, and how to debug a container that's already up and running. If you use Docker for long enough, this message is not a matter of if, but when. Every image you pull, every container you stop, every volume you create, it all takes up disk space. And over time, that can add up to tens or even hundreds of gigabytes of clutter.
Thankfully, Docker gives us a very powerful command to tidy up. Docker system prune, on its own, gets rid of dangling stuff. Add the A flag, and it'll remove all unused images too. But be extremely careful with that last part, -volumes. It will vaporize any volume that isn't currently attached to a running container. That could be your precious database, so use it with caution.
So what happens when a container is running, but it's acting weird, and you need to figure out why without stopping it? Well, your best friend in this situation is Docker exec. Think of it as a teleporter. It lets you run a command, usually to open up a shell, inside the live container. You can look at files, check running processes, and see exactly what's going on from the inside.
And of course, there's Docker logs. This is your container's diary. It shows you every single thing that the main application has printed out, which is often the first and best place to look for an error. And a pro tip, use the -F flag to follow the logs so you can see new messages appear in real time as you interact with your app. It's incredibly useful.
So if we boil it all down, this is your essential debugging toolkit. Docker logs tells you what the container has been saying. Docker exec lets you get your hands dirty and investigate from the inside, and Docker inspect gives you a complete blueprint of the container's configuration. Honestly, mastering these 3 commands will let you solve 95% of the Docker problems you'll ever encounter.
And that leaves us with one final thought to chew on. Fixing these problems is a fantastic and necessary skill, but the real next level is learning to write your Docker files and design your applications in a way that these problems never even happen. So the question is, are you just getting better at putting out fires, or are you learning how to build a fireproof house?